am the nature hacker, and this is your world. So I've been having some mixed results, I guess, with my noble metal battery. I've been working on sintering electrodes, and the sintering temperature is around 2,000 degrees Celsius, which is an oven, a sintering oven that gets that hot is like $10,000. So, this is for sintering molybdenum, which is what we need for the noble metal battery. Um, so I've discovered that um, that oxyacetylene torches get to be like over 3,000 C. So I was like, wow, I could use that to sinter, and it works. It works like a charm. But my first attempts, I had the oxygen up too high on the torch. If you look up like how to do the torches, like it'll tell you how to do a carburizing flame, how to do a oxidizing flame, how to do a neutral flame. So at first I was accidentally doing an oxidizing flame, and it just wasn't really working too good on the electrodes. When I would hook them up, and they would look good with a voltage of high voltage. The amperage was decent, around 30 milliamps for a piece, or quarter size piece roughly. So it's pretty decent, but 30 milliamps, it just wasn't really cutting it. So I kept trying, kept making more, and I got one that was giving me like 120 milliamps, but it was like, it didn't always work, it just, sometimes the voltage was 0.5, sometimes the voltage was 0.9, and it just, hard to tell what exactly was happening. But I think what the problem was is that my flame was too oxidizing, or in some cases my flame was too carburizing. So at the last time, and before I was mixing in magnesium oxide as kind of a filler to help, create pores in the metal. But the last time, I'm using a 20-ton hydraulic press to press these like little sheets of molybdenum, quarter size, like this. And what I do is I just sprinkle some powder, either mixed with magnesium oxide or just plain powder. In the last case, just plain powder, and then just press it as hard as I possibly can with a 20-ton jack. And and then I just, towards the end, before I was really burning the heck out of it with the torch, but at the end, it just kind of, just a light sweep over it, so it gets red. It turns the pressed metal powder red, and that's it. That's all I do. So it's very fast to sinter it. So at the last time, I was like, no more magnesium, I'm just going to try plain powder. And then I was just getting wimpy results, like 5 milliamps with, probably, 0.7, 0.8 volts, somewhere around there. But I flipped the thing upside down for some reason, and I just soaked it up with a lot of hydrochloric acid. And this is the molybdenum discs and copper, with a separator, and with hydrochloric acid, 32% hydrochloric is what I'm using right now. But I flipped the disc over. I'm getting 5 milliamps, just sucky. Flip it over, put some hydrochloric acid on the top of that thing, and then it maxes out my current meter. So I turn it to the 10 amp setting, and I'm getting 1 amp. I'm getting an entire amp. That's gigantic. That's as much as you could ever hope for a quarter size piece. A whole freaking amp. I checked, swap to voltage and look at voltage. Voltage is only at like 0.4, but still 1 amp at 0.4 volts. I mean, that's 0.4 watts just from that little teeny thing. Volts times amps is watts. So that is just insane, man. I'm getting an entire amp off of my dinky little piece of soldered molybdenum powder. Or not soldered, sintered with an oxyacetylene torch set to a neutral flame. This is big. This is really, really big. I could easily stack these things. I could make quarter-sized pieces. I could make like a little mold where I, die cast in the mold an actual quarter. I make a thing out of cement, and I stick a quarter in it, right? And then I let it dry, and then I pop the quarter out, and now I have a mold. So I could make quarter-sized pieces of this sintered molybdenum and get an amp off of it. So that means that you can put them in a tube. You could stack a quarter-size piece of copper, a little quarter-size separator, a quarter-size piece of molybdenum, blah blah blah. So it would go copper, separator, molybdenum, copper, separator, molybdenum, copper, separator, molybdenum, and yes, the copper touches the molybdenum on one of its sides. So anyway, we could do that. We could have a thing this big that's easily 12 volts, 1 amp. I mean, that is pretty freaking monumental. It would just be hydrochloric acid as the electrolyte. So, I don't know. I need to figure out how to go forward with this. I mean, my press is not gigantic, so I don't know if I can do big sheets of this stuff. So I don't know. Maybe if you could give me your ideas. I mean, it's a kind of a brittle molybdenum. You wouldn't want to like try to bend it. So it's like I don't know if I would really. I don't think I'd be able to make big sheets and make like a big lead acid battery out of it. So I'm thinking maybe like the roughly this size of a tube, and have these things stacked in these tubes, and each tube will be like 12 or man, shoot, if a tube's pretty big. I can't really do anything with the screen, but if the tube's pretty long, you get easily 36 volts, 1 amp out of it, which is 36 watts. So, and then if you want 100 amps, you just use 100 of those stacks. So I don't know if you could give me an idea of how to package it. The size of the sheets and how to do all that. So yeah, let me know what you think. Anyway, very exciting development for the noble metal battery. This is taking it to the realm of, this is only about 4 times worse than an aluminum air battery, which the aluminum air battery is already about 10 times better than lithium ion. So, and this battery is fully rechargeable. So, I don't know, folks. This could be a freaking revolution. So, yeah, help me think of how to, package this for use and stuff. So thanks for watching. I am the Nature Hacker. Do work.